So we saw yesterday circuit containing R only. In that, what we found? Was the phase difference in resistance only? Was the phase difference in circuit containing R only? No idea. It's there on a screen itself.
No, what did you ask? Sir, could you explain this again?
Yeah. I asked like what is circuit containing R only in that? What is the phase difference?
Pi by 2.
0.
So it's not pi by 2? Oh, no, sorry.
No. Pi by 2, it might be leading or lagging. See, both are in same phase. If you observe this one, they're also in same phase. They both are moving gradually and joining at this point as well as here. What's the difference here? Let's see. We will see this difference here in the next part. Next part in the sense, this was R, now only L. We'll study separately, then we'll combine all.
So could you explain the first one again?
Yeah, sure. Why not? Okay. So whenever we are taking circuit only R, okay, in that we have 0 phase difference. And in this one, as we wrote before also, in that like let it be AC or DC. In both, resistor occurs like work same manner. There is no leading lagging. So there is no difference between current and voltage phase. As we saw example of this one, this is leading. If it is minus, lagging. So there is no difference in phase for the only resistance, or we can say purely resistive circuit. Provided ohmic resistance. That is common thing. So whenever we are making a phasor diagram, so in that there won't be any difference in E and I. They both are moving in same place. Next, if we see, yeah, you got it, this one?
Yes, sir.
Anything you want to ask here?
So as impedance is resistance, it's equal, so it's in the
Yes.
same. That's it, right?
Impedance is our total resistance, but that is this, as it is only resistive circuit, that means Z equals to R. So if you write Z, you write R, it is same, doesn't matter. If I make a difference here, let's say next one. only inductor. L equals to E naught sine omega t. Okay. So same way here I mean I equals to I naught sine omega t minus pi by 2. Now here pi by 2 means 90 degree. So it is minus. So it is lagging. So if we compare with our standard equation, Z is omega L. So if I take here I naught equals to E naught by omega L. So here this is your Z omega L and this is your phase difference. So we can say that in purely it lag behind by pi by 2 and impedance is omega L. L is your inductor. Omega times L. So this is called as XL, inductive reactance. So we'll write like this. I naught equals to E naught by XL. Here we can write Z also because we have only XL here. But Z is actually total. XL, R or XC. Together it makes Z. So it depends if it has all three or if it has one or if it has two, means depends upon that. Let's see one by one. So let's first finish the graph portion. No, but phasor diagram. See here we wrote one line. We drew one line. If you can see this, there we said, okay, yeah, I and E are in the same phase. Now, how to make this as a 90-degree lagging? Can you tell me how to show that this is the 90-degree lagging? How to show this is lagging? Tell me. This is your X, E direction. This is your O. So how to show that this is 90 degree behind? No answer. This is current. So if I draw graph for it, so it lags behind and so on. So this is your I, this is your E. This is your omega T and E or I. That will be a peak value of E, and this will be a peak value of I. XL and frequency. This is the graph between XL and frequency. This is a phasor diagram. This is the graph between E I versus omega T. Resistance and loss. Now, if you compare with the capacitor, it will be totally ulta. Let's draw capacitor and compare all three. Have you done writing? I mean drawing.
Yes, sir.
Okay. Others?
Yes, sir.
Cool. चलो नेक्स्ट करूंगा ड्रॉ. For capacitor, you can try for capacitor. Come on. Have you tried?
Actually, I'm a bit backward of this chapter, so I'll check with the two videos and I'll solve, sir.
Okay. No, but I started just few days only.
Actually, yesterday and day before yesterday, my bus timing was changed, so I was a bit late. That's why I couldn't attend the classes, sir.
Sure. Okay, no problem. There are recordings available. I have to change the range. So E will be equals to, yeah, E naught sine omega t, and I will be equals to I naught sine omega sine omega t plus pi by 2. Wait, yesterday I gave some question. Okay, yeah, this one, right? At the end of this topic, I'll ask you those questions which I said yesterday. You remember or not? I don't know, but I remember that. So phase difference equals to pi by 2, that is plus sign. So if you guess here, you can draw this way phase degree, that is, you can just, same diagram, just interchange E and I. It will be I and this will be E. Or if you want the same direction, then E will be here, I will be here. That is also okay. XC and omega C. Sorry, frequency. Then graph
Sir, can you scroll it up?
just a second, please. So this will be I, this will be E. So this is your 2 pi, this will be your 3 pi, this will be your pi by 2. This one,
So could you explain how it's plus pi by 2?
in capacitor and this inductor, they are like working oppositely. They both work opposite. Actually, there is a full like one derivation for it. I just wrote directly formulas here. I'm writing here formulas only. Actually, one directly derivation for it. How to get this pi by 2 and all that. So if I want to make a short here, it will be time consuming actually. Okay, but I can just give you some explanation here. Like, see, as I said before also, like these capacitors, they are like their work is to charge little bit and discharge, right? So if we talk that way, an inductor is just a coil. Okay, both difference between them is like one. This capacitors is just taking it, and inductor work is to do both. Okay, simple terms. So as we compare here comparison is with voltage. So if we compare with voltage, see this resistor. Let's go with resistor here. Yeah, let's go with resistor here. In resistors, as we supply AC, there is no difference in AC and DC for the there is no difference between AC and DC in the resistor for the resistor. In inductive coils, there is a difference. That current will be leading, lagging in the sense like they are less less reactive current. They are less reactive current in inductive coil, but capacitive coil, as it is AC, it will be more reactive current. It will be highly reactive current. So we have made it as a plus I, pi by 2. So we are saying it's highly reactive, so it is plus leading.
So you're saying it's highly reactive.
Yeah. Capacitive is more reactive than inductive coils.
As it stores current, why is it more reactive than inductive?
Sorry, what?
So I don't understand why is it more reactive than inductive?
Inductive coils are like, it just a, let's make it more simple. Yeah. Inductive coil, it is just a coil. And capacitive is like its work, main purpose for capacitor is to like instantly discharge. Instantly. So instantly discharge in the sense like it's not like as yesterday she was saying about power bank, right? She was comparing with power bank. But exactly it's not a power bank of it, but yeah, we can compare with that. But instantly it is giving this, means whatever power it has, it is instantly giving discharge to, for the fan example as I gave yesterday also. If you take fan, without capacitor also it will work. It's not like that. Without capacitor also it will work, but for initial fast movement, we need to have some like fast power, initial power. So that way we can have this. So like likewise we are saying yes, capacitive is like a highly more reactive to this AC supply than inductive. I'm talking about especially about AC supply. DC it won't work. For getting these values, we need to do all this integration and differentiation things. That's why I'm skipping those things. But I can help you with that. Like, yeah, you know the formula for this charge and capacitors, Q equals to CV. Do you know this? Do you remember this? Charge and capacitors. Okay. So we can say V equals to Q by C. So this E we wrote E equals to E naught sine omega t. There we can substitute all this charge and all that. So I can say here, in place of this one, I can write here Q by C and or let's say here C epsilon naught sine omega t. Okay, from here. So we know I equals to what? dq by dt. Then if we substitute this one, then differentiate this one, then we can get directly this value. We'll get this. So differentiate part, you can do all that. Differentiation and integration part, you can do that. And you can get I value. If you want me to do like, then okay, then also okay. C will be constant, E naught will be constant, sin omega t will become cos. Cos omega t, and this will be omega will be outside. So C omega E naught cos omega t. So this one I can compare with I here. I equals to E naught by 1 by C omega cos omega t. But I want to compare with our original equation, that is sine. So if I want to convert cos to sine, I need to take sine pi, sine theta plus pi by 2 will give you cos theta. So that is why we have cos omega t plus pi by 2, then E naught by this one, that is x, this is c, so xc. So this is what we get here. Similar way you can derive for this one also. Here we need to use inductive formula. Same thing, like what is E formula equals to L di by dt. This thing you can use and solve it. This I'm not going to solve, but similar way you can solve this if you want. So as we go with this form, so as we can say here, like see, in this one I can add like in our pure inductor, like it is having very less ohmic resistance. You can say it has less ohmic resistance. That is the reason we can add there. That also reason we can add there. But mathematically, we got this formula here. You want to write, you can write, or else shall I erase it? I don't want this thing to here. You want to write, or shall I erase it? Yes, Samita?
Yes, sir, I'm writing.
It's like not required also, but that's what I was saying. No need to write, just for your reference. If you want, you can take screenshot and all that. Let it be. Now, if I add some points here also, like just now I got reminded, like see, if we go with the frequency wise, omega equals to 2 pi f, right? If for DC frequency is 0. So something divided by 0 is infinite. So Xc will be infinite value. So it won't work on DC. That's what we saw. We can say that. Condenser won't work on DC, or it blocks DC, we can say. Now if we go with this Mr. Inductor. So XL equals to omega L. So that is, if frequency is 0, then XL. So in that case, again, same like inductor also don't allow. It also doesn't like change anything with DC. It doesn't like do anything with DC. It only works on AC. And this guy, capacitor, works on AC only and blocks DC. But Mr. Resistance doesn't have anything. He is like, okay, I'm okay with everything. He's like India right now between Israel and Palestine. Okay. Just removing it. It takes much space here. Oh, it's time. Okay. Fine. Okay, then combination of all these three we'll see next class, because anyhow it's time now.